Thank you very much, Mr. Thang Leung, on your talk. What do you think about music and AI? The two topics seem belong to two different worlds. But in our next talk, Bao-Dai, an NLP research scientist from Knorex and the senior lecturer of VietAI will change your mind. Bao-Dai will introduce a tool for artists to use when working and developing new songs. Some current models cannot produce long-term structure for pop melodies, which help shape a pattern for every pop song. Also, tonality is lack in every machine-generated composition. So please welcome Bao-Dai to share with us on the topic, generating Vietnamese pop melody with tension-based encoder-decoder. Please welcome on stage.
Good afternoon, everyone. I'm very happy to be here and introduce myself for you. My name is Bao-Dai, and currently I'm working as an NLP research scientist at Knorex, and I also give lectures at VietAI Foundation classes. Additionally, I'm also work with music at Adam Studio, and today I will talk about music generations. I know that music generation is not a hot field when you apply AI, because I think it's not really revenue-driven project rather than NLP or CV. However, for musicians like me, music generation is really interesting. And yep, today we will talk about the model called LSTM, encoder-decoder with attention. So let me try to define the problem first. As the name say, the model can generate music like pop melody, and in this problem I try to generate Vietnamese pop music, and in the training phase I input the melody of pop songs, and we try to make the model generalize the style, the idea of Vietnamese pop song, and in the inference phase we try to input a priming short melody. Priming melody is a short melody that can show the style, the vibe of the songs, and we hope that the model can output the full song, and that's the problem. Okay, and you may wonder that how can we input the file, the music file into a model, and the secret is we use all the input and the output as MIDI format. For example, we have input here, and we have outputs here. As you note that for the input we have 3 notes, and in the output we have 6 notes. And the 3 added notes by the model has the same pattern with the input. As you can see, this is the same. I mean the length of the note. This is the quarter note with the dot, the 8th note, and the half note, and the same here. Yep, this is just a toy example for you to understand the problem. Okay, and every MIDI file is converted into a vector based on events of the melody. There's 3 kinds of events of the melody. Firstly, we have note on event. The note on event is when we play a note and we turn off any other note is playing. And secondly, the no event. The no event is the event where we continue to sustain a note, or otherwise we continue to be, the notes continue to be silent. And lastly, we have note off event, and we just turn off any currently playing notes. For example, we have 2 bar here, and we have 6 notes on event. Note that we don't need to have the notes off, because in the notes on we turn off any other note that might be playing at the moment. And we have notes off at last. We have no event between the pair of notes on event. And we can convert the notes into vector like this. As you can see, we have a green number, the yellow number, and the red number. The green number is note on event. We have 88 keys on the piano, so we have 88 green number, and 1 yellow number of the note event, and 1 red number for the note off. Okay, and there are some requirements for machine composers, things we need for machine composers. Firstly, it can generate a melody that sounds like a pop song. I see that there are many models that can generate music. However, it's not like, sounds like a pop song. It's just a jazz or some random notes, I don't know. I mean, it's a catchy melody. Secondly, the model has the ability to create a long-term structure. A long-term structure help you can help people to remember the songs, and as well as aware of pattern in the songs. That's some requirement at first. So I think that we can use LSTM to solve the problem. So this is the 5 famous formulas of LSTM, and I think you should have familiar with those formulas. So I will skip that due to some time constraints. Okay, and using the architectures of LSTM, we build an encoder-decoder, and we just input the vector of the melody into the encoder, and we take the output after the process of the decoder. And after that, we also use beam search to get the most relevant in the top candidates. And also we use additional features here. We use the features that repeating event of 1 or 2 bars ago. Bar here, we have 2 bars here, the first bar and the second one. Those 2 ones is separated by a line. And also we use a flag to decide whether the last event was repeating from 1 or 2 bars ago or not. And we also use the current positions within the bar. For example, the first position is 00001, and the second one is 00010. It's the same as the binary representations of a number. However, we use -1 and 1 instead of 0 and 1. This is proposed by Daniel. Okay, and we also use custom label when training model, because you know that LSTM can take the output of the last timestamp to input to the current timestamp. So as long as we use additional features, we need to have custom label, and we have three kind labels: label of repeating 1 bar ago, 2 bar ago, and label of specific melody event. And using this kind of label can help can facilitate the model to repeat sequences of notes without having to store them in the save state of RNN. Okay. And I also use attention mechanism in LSTM. Can you please hit the button? This animation I take from Alamar. So this is the attention as time step 4. However, it shows the idea of attention. And we use the formula to compute the score of attention. And I think that you have been already familiar with attention mechanism, so we try to skip that. And for the data, this is the more challenging thing when I work in music generation problem. You know that we need to generate pop song, and specific for Vietnamese pop song. So for the data, we don't have that officially, so I need to collect them. The source is MIDI file, and I take from some forum, and there are some MIDI files contributed by the members of some music forums. And I also play on the keyboard here to produce MIDI files. And the advantage of the manually produced MIDI file is it has no noise, so we can use that. However, it takes time. And here's some number. The total MIDI files I use is nearly 30K of MIDI files, and the length range is about 1 to 2 minutes per file. And for the pre-processing part, you know that when I take the MIDI files from forum, there's some kind of noise, many noise. So I try to remove all the melody line or percussion in a MIDI file, and then transpose all the song into C major or A minor. For example, all the MIDI files is like that. We have guitar, piano, and some drum percussion, and I try to remove them all except the main melody. So for example, in this song, we can see that it's the song named Oceans. So we just retrieve the main melody, which is the guitar here, and remove all the piano. After that, we need to transpose the song into C majors, which means there's no sharp or flat in the key signatures. For example, this part, the transpose, you can hear the song. I can play for you. Oops. Okay, can hear. Okay. This is the song named Oceans. The first line. This is the first line, and the second line is the same but in a different key. You get the idea, right? Sorry, you get the same melody. However, we just take all the song into C majors. It's like a normalized step for melody. Okay, and this is the demo. Firstly, we have the input. Can you please hit the button? Yep, thank you. No sounds. Okay, thank you. That's the input, just the 4 notes. Oops. Can you also, yep. This is fa, mi, fa, mi, do, la. Okay, just 4 notes. And this is the output, the combination output for a machine. That's the output of a machine. Thank you. And for the 4 note, we have the full song like that. So it's inspired me so much. So I try to manually arrange that on door. So we have the next level of this song. So this is human-made, right? Arrangements. I add the intro. Arrangement of the song. Okay. Thank you. And the next level of this is a song with lyrics. So I try to write some lyric. However, I haven't recorded it yet. Okay, we just start at the arrangement. However, I think everybody has their own lyrics for this melody, right? So that's the demo for the model. And I just want to analyze the song for a little bit. This is the rhyming melody, just the 4 notes. And the title, I named this the AI love song, since the melody sounds beautiful like the love song, right? The song is a combination of many melodies from MIDI file exported by a machine. So the chorus does repeat the pattern of rhyming melody. So you guys may note that we have then that's the pattern of the chorus, and we have verse for that. Model also produces other specific melody events, so I use that for the verse. Okay. However, we have some drawback from the model. The generated melody sometimes doesn't sound like real like melody in Vietnamese pop song. As you know that we have senston here. The ending sentence jump around and make some not really sounds like a pop melody. If I were the composer, I will write smoother, right? This is the Vietnamese pop songs. Really sounds like it's not okay. So sometimes it doesn't sound really like melody in Vietnamese pop songs. So and another thing is it can just generate melody, not the whole song. I need to combine all the export MIDI file to produce the whole song, and still need human to touch and mix the results. As you can listen to the arrangement, I need to make it on the digital audio workstation. So, and the last thing is no lyrics, no generated lyrics and harmonies. If I name the song the I Love song, and for the artist, maybe I can use artist model checkpoint 20134 featuring me or something like that. So at the first, I just don't show that generating Vietnamese pop song. We just generating melodies. Okay. And for future work, maybe I can work on the lyrics and the harmony part. So for the lyric, I try to combine with the language model to generate lyrics. However, we have a challenge here. We have Vietnamese accent diacritics. So it's harder for writing a song in Vietnamese rather than in English. And for the harmonies, it's about the chords. So we have many line of harmonies for just only one line of melody. For example, we have 3 variants of just only one line of melody. If I have time, I will play for you these 3 kind of variant. However, I just have time constraint, so maybe I will skip that. Okay, and as you know that for the harmony, there is a model can generate harmonies. Maybe you can try to use that. This is Doodle from Google, the birthday. Maybe you can try to Google search the Doodle. Okay, and for the contributions, I just want to wrap up about the data. We have about nearly 30K of MIDI files for Vietnamese pop song in MIDI format. And the model, we can use that as a pre-trained model. And also I contribute some PR for Magenta of TensorFlow. I have some PR for Magenta, and yes, they merge straight into the master branch. Maybe this is nothing to somebody, however, it's really an experience to me. Maybe, yeah, this is, I just want to mention that if you have something, please share. Sharing is caring, right? Okay, that's the end of the talk. So maybe you can, my talk can hopefully my talk can inspire you to work with music in AI, and hopefully you can know that how the model can facilitate the process of composing a song. So thank you. Sorry, maybe we don't have enough time. Maybe next time or in the end of the summit. Okay.